Okay, so I want to continue with this problem again and come back to this. Here's our ice table again. Here is our KP setup, simplified now after cleaning up our mess. Remember the quadratic formula from mathematics classes, right? So for problems where we have an x squared, an x, and an integer value equal to 0, right? We can solve for x by using this quadratic formula that we should be familiar with, right, in the purple here. Remember that since we have a plus and minus, this will give us two values. Okay, so I've used our example where we got to this this quadratic form with our squared value there, and plugged it into the quadratic equation to solve for x. Okay, so now I'm going to take a moment and solve for x. I've not done that yet, so we'll do that. We'll see what our two values equal. Okay, coming back. So I've plugged in my values. I've now solved for everything in the square root and then taken the square root of it to get 1.445. So I can get two possible values here for x by solving this. I get 2.744 or 0.0915. Now, sometimes we get a negative value as one of those two values, and a negative value for a equilibrium concentration obviously cannot be. And so that would be necessarily not valid, and the other one should be okay. However, in this case, we're going to look at these two values for a moment, and if we come back, knowing that we started with 1 atmosphere of gas, okay, it's possible but very unlikely that we're going to end up with 2.74 atmospheres of another gas. Okay? Especially given the value for our equilibrium constant. So let's take a look. So, considering our two options, if x is 2.74 something, we get a very negative value for the equilibrium concentration of NO2, and so that can't be. Okay? If x is a smaller value of 0.0916, right, then that makes our equilibrium concentration of NO2 to be approximately, about 0.8 something, and this value to be 0.0916 atmospheres. And that's more reasonable, right? So we need to double check, see if that would plug into our KP value and work out to be a value similar to that. We can take these partial pressures and then solve for total pressure. Like I said, this is a gas reaction. Just because we start with 1 atmosphere of gas does not mean our products have to total pressure of 1 atmosphere. So we want to consider that. What can happen depends on stoichiometry of the reaction. In some cases, a gas reaction will give us a larger pressure or a smaller pressure. So if it's not equal to the same pressure, that's not a red flag. So I've worked through this one to complete it. I wanted to make sure I showed you that. You do need to look through some of these on your own time, and I'll give you a little bit of class time to work on some of these as well in the coming week. All right, thanks. Goodbye. Have a good day. Sayonara. Salut. Au revoir. Have a good break.